Welcome back, friends. In this session, we are going to look about the pressure and volume deviation of real gases from the ideal behavior. Don't forget to subscribe to the channel, to like the video and share the link. If you have any question, just comment below or visit my Telegram group. There it will be easier for you to discuss with me. Now, tunasema kwamba at high temperature, the gas molecule are moving fast, that the kinetic energy they possess, they tend to break any possible force of attraction. Therefore, intermolecular force of attraction is negligible at high temperature. When the temperature decreases, the molecule moves slow. The kinetic energy they possess is not enough to break the intermolecular force of attraction. Hence, the intermolecular force of attraction is not neglected. The intermolecular force of attraction between gas particles is not neglected. Therefore, the gas does not behave ideal gas or ideal properties. May say does not behave as ideal gas or does not behave ideal property. Now, hiyo tunazungumzia deviation ya pressure. Kuna effect kubwa ya intermolecular force of attraction kwenye pressure au kwenye properties za ideal gas. Now let's look on the effect of intermolecular force of attraction on the properties of ideal gas. Effect of intermolecular force of attraction on the properties of ideal gas. Now, when the intermolecular force of attraction between the molecule are significant au zimeongezeka, the measured pressure of the real gas become less. Hiyo ni kwa nini? Tunapokuwa tuna container kama hii, alafu tunakuwa tuna gas molecules. Hizi gas molecules tulisema mwanzoni kwamba the collision between the gas molecules themselves and between the gas molecule and the wall of the container ndizo ambazo zinatengeneza pressure kwenye hii container. Kama kila gas molecule hapa ana move kwenye 3 dimension. Hasa kama molecule watakuwa navutana, ule mvutano kati ya molecule utapunguza velocity yao. Mvutano kati ya molecule utapunguza velocity. Yani, when the intermolecular force of attraction increases, intermolecular force increase, manake hii hapa itapelekea nini? Velocity ita decrease. Root mean square speed ita decrease. Decrease root mean square speed, hence force of collision and hence pressure ita decrease. Kwa unaona intermolecular force of attraction they are inversely proportional to the pressure of the gas. Intermolecular force of attraction zinavyoongezeka, pressure inafanyaje? Inapungua. So when the intermolecular force of attraction between the molecule are significant, the measured pressure of the real gas become less than the pressure predicted by a real gas equation. So pressure of the real gas ambayo ina intermolecular force of attraction is less than pressure for ideal gas. Kwa sababu kwenye ideal gas tuna neglect intermolecular force of attraction. Kwa unachokuja ukiona ni kwamba pressure of the real gas is less than the calculated pressure from the ideal gas equation. Note that for real gases, the increase in external pressure compresses the gas, hence decreases the volume. For real gas, increase in external pressure. Kwa kama tukawa na container hii hapa. Container hii hapa. Let's say imejaa gas mpaka mle. Then hapa tukawa tuna atmospheric pressure tu 1 atm. Atmospheric pressure 1 atm. Lakini mwingine pale akawa na container ile. Hapa kaongeza pressure ikawa 2 atm. Hii pressure maana ita compress volume. So volume up maybe ilikuwa 2 liter, hapa itakuwa 1 liter. Hapo kumbuka number of moles of the gas zimebakia vile vile. So that is what happens in real gases. For real gases, increase in external pressure. External pressure na compress the gas, hence decrease the volume. Kwa hiyo sasa unachokuja ukiona ni kwamba decrease in volume of the gas means contraction. Concentration increases. This leading to decrease the average distance between the gas molecules. Hence, intermolecular force of attraction is introduced. Kwa hiyo unavyoongeza external pressure, pia unaongeza the force of attraction between the gas molecule. So factors affecting the extent of deviation of real gas pressure from ideal gas pressure. Tunaangalia pressure deviation. Lakini extent ya deviation ya pressure inakuwa affected by 3 factors. The main factor which determine the strength of intermolecular force of attraction and therefore the degree of deviation of real gas pressure from ideal gas pressure. Kwa hiyo strength ya intermolecular force of attraction is determined by 3 factors. One ni nature of the gas. Nature of the gas. Lakini pia ni temperature. Na tatu ni concentration. Nature of the gas. Different gases zinakuwa zina different forces of attraction. So each gas has unique structure which is attached to different strength of intermolecular forces. Example, ammonia show greater deviation of its measured pressure from the ideal pressure than nitrogen because ammonia has intermolecular hydrogen bond than London dispersion forces existing between nitrogen. Kwa unaweza kuona kwamba different gases zinakuwa zina different intermolecular force of attraction. Hence deviation yake inakuwa tofautiana. The stronger the strength of the intermolecular force of attraction, the larger the deviation. Kwa sababu deviation inasababishwa na nini? Na intermolecular force of attraction. Intermolecular force of attraction inapokuwa strong, deviation inakuwa kubwa. Hydrogen and helium show small deviation because they possess weakest London dispersion forces. Lakini kwa zile gesi ambazo zinakuwa zina large London dispersion forces, hence zinakuwa zina deviation kubwa. Our second factor is temperature of the gas. The lower the temperature, the stronger the intermolecular force of attraction. As we said before that as the temperature increases, what happens? The temperature breaks the intermolecular force of attraction between the gas molecule, and hence at the end of the day we are ending up with this smaller deviation. So temperature inavyozidi kuwa ndogo, deviation inakuwa kubwa. Hence the real gas pressure deviates from the ideal pressure. Gases show maximum deviation in their boiling point. In their boiling point, manake boiling point ndo maximum point ambayo gases zina exist as gas. Here, this is not boiling, this is melting. I mean, yeah, it is somehow like freezing. You know, when gas they freeze or they lose heat energy, they become liquids. So boiling point, it is not the point in which gases they. Okay. Anyway, somehow maybe I have confused these two terminologies. I will explain them more in the next session. Lakini ndio hivyo, pale ambapo gases hazijaliquefy because actually they did not freeze, gases they did not become solids. So, and if we say melt, anyway, maybe I have confused this. I think it is boiling. Kwamba boiling ni ile point ambayo gases zinaweza kubadilika kuwa liquids. Hiyo manake ni lowest temperature ya gases coexist. Ukidecrease temperature zaidi hapo zina become liquids. Hiyo ndo temperature ambayo gases zitakuwa zina higher deviation. Kwa sababu the temperature decreases, the deviation increases. Kwa hiyo hicho ndo ambacho tunatakiwa kuelewa. Temperature inavyozidi decrease, deviation inaongezeka. Our third factor is concentration of the gas. Kama tulivyosema pale mwanzoni kwamba unavyozidi kuongeza external pressure, unaongeza concentration of the gas na una increase in the molecular force of attraction. The higher the concentration of the gas, the shorter the average distance between the gas molecule. And if the gas molecule are close to each other, they will be able to experience the significant intermolecular force of attraction. Now the greater in the attraction away from the wall decreases the pressure, against the wall component to it would be if there were forces of attraction in low concentration between the molecule. Hence, the molecule in the gas with greater concentration on pulling each other to the center of the container, hence decreasing pressure Lil. So concentration of a gas can be increased in two ways, because concentration ni number of moles divided by volume. Concentration unaweza uka decrease volume au ukaongeza number of moles to increase more gas more. Kwa by any of these two methods unaweza uka increase the concentration of the gas, and by increasing the concentration of the gas you increase the deviation of the real gas from the ideal behavior. So tunaweza kufanya recap. Nature of the gas. Nature of the gas inadetermine nini? Intermolecular force of attraction. Intermolecular force of attraction. Tunasema stronger intermolecular force of attraction manake ni higher deviation of the gas. Lakini kwenye factor pili ambayo ni temperature, higher temperature itapelekea nini? Small deviation. Lakini kwenye concentration, higher concentration itapelekea higher deviation. So in summarization we can say intermolecular force of attraction, increase in intermolecular force of attraction is direct proportional to the deviation. Then increase in temperature is inversely proportional to deviation. And then you can say increase in concentration is direct proportional to deviation. Deviation of real gas from ideal behavior. So this is simply pressure deviation. In the next period tutaangalia kuhusu volume deviation of real gas from ideal behavior. Thank you everybody. Subscribe the channel and share the link to your fellows so as to assess these states of matter periods. Kwa hiyo nikutakie tu usomaji mwema. Thank you.